So I think we'll be able to get started now. Hi, everyone. Welcome to our Sentry AMA live stream. Today, we're really excited to have you, and we're going to talk a little bit about profiling. If you're an engineer or developer, chances are you've experienced the frustrating and time-consuming process of finding a performance bottleneck, whether you're digging through logs and traces and metrics, or manually needing to instrument some code to see what was going on. And if that sounds familiar, you're in the right place today here. Today, we have some of our engineers who are building profiling, Sentry's latest performance monitoring product feature, on the line. And they'll be sharing tips and best practices for how you can use Sentry to identify and solve your performance bottlenecks at the code level. We'll also be answering your questions today, so feel free to leave those in the Q&A as we kind of continue talking throughout the live stream. So yeah, as I intro the team, please feel free to intro yourselves in the chat if you haven't already. And this is our live stream team today.
Hey, I'm Indraji. I'm the Director of Engineering for the Profiling and Session Replay products. I'm based out of the SF Bay Area.
Hey, everybody. My name is Ashish. I go by Ash. I'm the product manager supporting the profiling product, and I'm based out of New York City.
And I'm Linda. I'm a product marketing manager here at Sentry, also supporting the profiling and performance teams. And I'm really excited to be here today with you. Great. In this live stream, we'll have Ash go through a quick intro of what profiling is and how it works. And then Indraji will give a live demo of the profiling product, from a basic workflow with tips on how to read a flame chart, all the way to how you can solve a couple of specific use cases. And then we'll start answering questions. But of course, feel free to drop those in the Q&A as we go along. And before I hand off, just a quick overview of why profiling might be valuable to you. Today, Sentry can provide full stack visibility into your application performance with features that get you closer to understanding latency issues. You can trace slow loading pages all the way back to poor performing API calls, and you can track the metrics that matter to your app performance, whether it's Google's defined web vitals or slow and frozen frames on mobile. We can also point out your slow transactions based off of suspect spans and tags, and you can see changes in performance over time using trends and graphs. And lastly, we're also surfacing performance issues in your issues feed to quickly triage, assign, and resolve. So you know what's slow, but getting to the source of your bottleneck might be a little bit more tricky. You could have missed adding some instrumentation to something in the critical path, or you might be testing in an environment that's different to ones a user is experiencing. So wouldn't it be nice if you could pinpoint and take a magnifying glass to your code and see exactly why the performance issue might be occurring? As part of our performance offering, profiling can now help you quickly find and fix your performance bottlenecks. This means that you can drill into the functions and lines of code that are causing the issue, rather than grokking through logs and traces and metrics. And you can do this all in production. So we automatically collect real user data in production, and profiling helps reduce that manual effort of maintaining tests and tooling, and can cover more usage patterns there as well. Profiling can also help identify hot code paths so that you're able to optimize your resource consumption before users feel the impact of a slow request. And that might be seen, surfaced as a stuttering scroll or lag screen. And then lastly, profiling can also fill in missing instrumentation gaps and save you the effort of manually adding in spans to see what the issue is. So at the end of the day, profiling is helping to make performance more actionable and to speed up the troubleshooting process. So now I'll pass it on to Ash to talk a little bit about how profiling works.
Thank you, Linda. So first things first, just to give a clarification on the kind of terminology that we typically use here at Sentry for our product offerings. You've perhaps familiar with some of these terms or heard some of these terms within the product itself, tracing and profiling and performance. Just to kind of give you a holistic view, the Sentry performance product originally was largely a tracing-based product, meaning it enabled you to view performance issues by looking at what we call traces, where for particular services, we could record the entry and exit time for when a particular service is triggered by recording what we call transactions. So, for example, you're running a backend service and a particular service is invoked. From the time that service is triggered to the time that it completes its operation, that would be considered a transaction. And within that transaction, it further breaks down into the individual kind of constituent elements of the work that's done in that transaction, which we call spans. For example, a span might be a database request. And the start and end times for all of these components are recorded, such that you have a view and a breakdown, which we offer as part of our performance product, that enables you to see exactly how much time is being spent on all the various operations, or rather the transactions and the spans within your application. What that didn't provide up until now was specific visibility into what code is being run, like what is the actual line of code which is being run within a particular span. And that's kind of where profiling comes in. So the Sentry performance offering today offers tracing supplemented with profiling, such that when you look at a higher level and you can examine within a particular transaction and a span, like what is the actual code being run, profiling offers you an actual trace of or an actual record of the exact stack of functions, the call stack of what is being called and what is actually happening. In a precise record, so that you can see exactly what line of code is being executed and be able to attack that particular line of code to address whatever the performance issue might be. To take you a little bit more detailed into what the actual functionality is and how profiling works. Okay, so how profiling works. Essentially, the Sentry profiling engine will be running within your application, and it samples the call stack every 10 milliseconds to collect the exact sequence of what operations are running and what code is running over time within your application. This sequence of stack traces is presented as what we call a flame chart, which is what you're hopefully able to see on the screen right here, whereby the entirety of all the code which is executed over time, you can see the specifics of what of all the functions and what the stack of functions is at each moment in time, such that you can look linearly across this chart. And over time, you can see exactly which functions are being executed. Now, to actually address this or to actually interact with this, an initial starting point is the performance landing page, which is currently part of our performance product. Bringing this up, so within the performance landing page, you are able to actually view all of the transactions that you might be interested in interacting with and viewing detail information on any of them. Selecting a transaction from the list here will bring you to the transaction summary page, which looks like this. And with the new supplementary profiling information, which is available as part of the profiling product, you can, for a particular transaction event, for a particular event that took place, you can select the profile, which is boxed here, right? By selecting that profile, it will take you directly to the flame chart. So this is going to be the actual representation of the code that's being executed in in stack trace form over time so that you can see exactly where you're spending all of your time within that particular transaction event. And to give you some further information with regard to how we interact, like with the other ways in which profiling information is incorporated into the Sentry performance workflow, looking at the transaction span view, when examining a particular transaction event, you can also enter what we call the span waterfall, where for a particular transaction, it breaks down into all the constituent spans, all the time that's spent in that transaction. And here, you can actually click on any individual span, much like in this example, and it will supplement with profiling information to show you what is essentially going on within that span. So looking at the image here, you see for this stack, or rather for this span, the interface will present to you a stack of, rather the stack which occupies the most execution time for that particular span. So yeah, you can see here that this particular stack, this particular code path is what's occupying some 89% of the execution time for this span. Clicking through this, you can cycle through and see what different code paths are actually occupying this particular span as well in like decreasing order of share. And finally, from the profiling landing page itself, so within the Sentry offering, we have the original performance landing page, which I've been talking about thus far. We also have profiling as its own landing page, which enables you to more directly view profiling data immediately, rather than going through the performance workflow. And from here, what you can do, you are immediately presented with a list of all of the transactions, along with data on what functions are actually taking the most time from within those transactions. So in the top left corner, you see that we've selected, or we present to you the slowest transactions with a breakdown of the top 5 slowest functions within each of those transactions. Furthermore, you can actually hover your mouse over any of the individual transactions in the transaction list, and a hover card will immediately pop up that is populated with the same list, showing you the slowest functions within each of those transactions. And then finally, selecting a transaction from this list in the profiling landing page will bring you to the transaction details, or rather the profiling transaction details for the selected transaction, in which you are presented with what we call the flame graph. So here, for a particular transaction, it might actually have many different events that are associated with that transaction, where rather than being a single event which took place on like, a single, process, you're taking a group of events within that transaction type and aggregating all of the information from them to produce what we call this flame graph. So in this circumstance, rather than being a temporal chart, which you read from left to right, where it's actually showing you over time what happened, we take a whole bunch of sample events, combine our sample data to give you an average representation for all of those representative events of where time is being spent within your call stack. And you can see here, essentially the width of each of the bars in this flame graph represents on average how much time is being spent within the call stack for that particular code path. So this is a good way of getting an aggregated information, or an aggregated sense of where the actual execution time is being spent for your particular transaction. And that's kind of an overview of how you would interact with profiling and how it works in general. And now we will move on to the actual demo, which, last slide, apologies. To set up profiling, it's a very simple process in terms of you have to ensure that performance monitoring is set up for your particular SDK. The total code really required to get up and running is no more than 5 lines. I cut and paste here the example, which is for Python. But for all of our supported SDKs, really it's going to be no more than 5 lines in pretty much every circumstance to get profiling up and running. The instructions for SDKs on a per SDK basis are all available in detail within Sentry documentation. And now I think Indraji is going to take over with our demo.
Cool. Thanks, Ash. Let's jump into it. So this is the profiling landing page. So Ash just showed this briefly. So at the top of the profiling landing page, you see a list of the slowest transactions in the project that you've selected. And so, for example, here at this API endpoint, we can see that these are the slowest functions ranked by total self time. So basically, out of all of the kind of events that we've ingested, we know that retrying redis cluster.execute command takes 2.9 seconds of total execution time across 223 instances. And so you can see for your top 3 transactions what those functions are in this card. And then for your other transactions, you can hover over the transaction name and you can get the same function level information. So let's jump into an example of a particular transaction and see what the data looks like. So if I go to the events endpoint here, project/events, and I click on the bigtable kv storage.getMany function, you will see that I have a flame graph here, a flame chart, sorry, that will highlight all of the occurrences of that function. And so you can see that the function here is highlighted 3 times. It's being called once for 23 seconds, once for 1 second, and again for 4.76 seconds. And so before I kind of explain more here, I want to sort of give an overview of how you generally read a flame chart. So the flame chart in this case is a visualization that lays out profiling data, the function data, where the x-axis is time. So you can see that the time axis here starts at 0. It goes through to the length of the profile. And on the y-axis, we have stacks. So starting from the root here, if I scroll all the way up, this is sort of like the root function, which calls this function, which calls this function. And eventually, if you scroll all the way down, you end up at the leaf function. So at the leaf, we always have a condition.wait in each of these stacks. And so the width of the frames here represents the total execution duration. So this frame is long because it takes 23 seconds. And so this is sort of like the highlighted view that shows us the function that we came here from. And then if I want to kind of customize this view, I can color code it in different ways. So our default color coding is what we call this system versus application frame color scheme, where the code inside your application is highlighted in blue, and then the code within, for example, the standard library, the Python standard library, will be highlighted in a different color, will be highlighted in this beige-ish color. I can also switch over to a different color scheme. So symbol name would highlight these in different colors per function. Package highlights by the package name, and so on. So there's a couple options here for recursion, frequency, which will all show the same data, but just color coded in a way that signifies some third dimension. And so besides like the function data here, we have a couple other things. So over here, we have the spans from the transaction. So this window here renders the span information. So each of these blocks is actually a span, and then you can kind of see it in line with the profiling data. You have the same data down here in a tree format. So if you can filter down to application frames, and you can kind of just get a call tree representation of the same data that's in the flame chart. And then finally, you have some stuff here, which is just kind of like the metadata, the transaction, the release, the environment the data was collected from. And then at the top here, we have the thread selector. So in this case, we've selected the thread automatically that where the request is being handled from, but you can also look at the other threads in the process. We have some additional options here for kind of sorting the order of the frames with alphabetical or left heavy, which kind of moves all of the most expensive frames to the beginning of the flame chart. And then you have some search functionality here where you could, for example, search for specific frame names. So that's kind of how the flame chart works in a nutshell. And so going back to the original landing page, that was an example of looking at a specific profile event. So we're looking at a single profile collected over a single run on a single kind of host. And Ash in his kind of overview also mentioned that we aggregate that information. So for example, if I go to, if I click on a transaction name here, it goes to the aggregate flame graph, which shows me data that comes from us collecting many profiles across many hosts, many kind of runs, and then putting them together into this sort of aggregate representation. So this is like the flame chart, except instead of focusing on a single profile, this is data from multiple profiles. So you can see here that the system frames are hidden by default. I can always show those, but for kind of clarity, I will hide the system frames and focus only on application frames. So what I see here is the width of the frames here indicates the frequency of that kind of call stack pattern appearing across profiles. So the biggest kind of widest frame we have here is this project artifact lookup endpoint.dispatch. And all of these call through to bigtable kv storage.get menu, which is one of the kind of hot functions that we identified earlier on. So you can see here, like this function is called from a bunch of different places. But the kind of most common place it's called from is this project artifact lookup endpoint function. And so this kind of tells you where you kind of want to start looking for call sites of this expensive function that you might want to start optimizing from. Another kind of way to look at profiling data is by looking at a single transaction event. So let's say you open a transaction span waterfall for a single transaction, and you are looking through the spans here, and you find this really long span where you're kind of unsure like where this exists in your code. So this serialized span, it takes 920 milliseconds. We kind of get an understanding of what is running within the span through the subspans, like the select database queries you can see here. But if you click on this, you will immediately get profiling data that shows you kind of the exact code path that is most prominent in this particular span. So we know that this particular call stack pattern appears in 89% of the samples collected for this span. And you see here, we've identified some functions. So this one looks interesting, the user filter query .apply filters. And if we want to look into this with more detail, we can click the view profile button, which will take you directly to the full flame chart for that particular call stack. So we can see here that the serialized span is highlighted. This is where we kind of started our investigation. And then if I look directly under that span, I can see the associated profiling data, including that user filter query.apply filters function. So we can actually see here, based on this data, that this is responsible for the majority of this runtime. It takes about 811 milliseconds. And just looking at the sort of like the span information here, we can see that it's doing a whole bunch of these database queries, these select calls. So basically what we understand from looking at this is that this user filter query.apply filters is a function that executes a lot of database queries. And as a result, it takes 811 milliseconds. And so if we want to find out more about this function, we can actually right-click the function and open the code in GitHub. So now it's going to go directly to our source code, where indeed you can see it's putting together a whole bunch of queries into a list that are then executed. And so this takes you directly to your source code. And that's kind of sort of the point of profiling, right? It's taking you directly to the source code that's causing your performance problem. Another case where profiling can be really helpful. Let's go back to another example of another transaction. So you're scrolling through this one and you see that you have this missing span instrumentation span. So what this is telling you is that in this particular case, we have 797 milliseconds of time that's unaccounted for. So we have spans for a bunch of things in this transaction, but for this particular time period, we actually have no idea what's happening. Normally, this would mean that you would need to kind of hunt this down in your code manually. You would try and find the place where you have a missing span and you have to add manual instrumentation for that part of your code. But if you have profiling, you can just click the span and it immediately gives you a snippet of the profile data, showing you kind of the code that's running within this span. So we know that the 797 milliseconds predominantly comes from this get series function. And so if I want to go and see more detail, again, I can go to view profile, which will give me an example of flame chart with the entire context. And you can see that the missing span instrumentation, I've highlighted that span here, and then directly underneath it, we see that get series function. It tells you the source code, the line number where that function exists, and we kind of know that that's okay. You can again open in GitHub, so you can go directly to the code. Oops, GitHub is down, as we know, so this didn't work. But if GitHub wasn't down, you would be able to go and see the source code for this get series function, which would kind of tell you where in the code to look to start optimizing it. And the final example that I want to show you is what we call performance issues that are powered by profiling data. So Sentry released performance issues a while back, and this was sort of a way of creating issues for things that are for situations that are common performance problems. So essentially the idea is you enable performance instrumentation, you ship your app, and then for common sort of performance scenarios where you need to fix something to improve app performance, we create an issue for you with the relevant details you need to kind of debug the issue. Similar to how Sentry creates issues for things like errors and exceptions, except this is for performance problems. And so the way we've extended this is for profiling, we've created more of these performance issue types, but these, instead of being powered by transaction and span data, are actually powered by profiling data. So in this case, we have this issue type called image decoding on main thread, which is a performance issue type for mobile apps, specifically on iOS and Android, where we detect when you're doing a bitmap decode on the main thread that takes a significant amount of time. So in this example, you can see I have this transaction called analyze image, where I'm calling this function somewhere, copy image block set. This is a system like standard library function. And that function is taking 36 milliseconds, which represents about 65% of the total profile duration. So underneath that, I get a full stack trace. So this shows me exactly where in my application code I'm calling this function. So we basically have this code function called find color components, and we have like a file name and a line number for it, and that's calling into a system API that results in a bitmap decode. So if we want to get more information, like you might be fine with just a stack trace, and that might be enough to debug the problem. But if you want to view kind of the full context, again, we have this view profile button, which will take you directly to the profile. And then so we can see more here. So we can see the full call stack for where exactly this function is called from and some of the stuff that that function calls. So basically what we're seeing here is we have this find color components function within our app code that eventually calls down to a CG context draw image, which then does a JPEG decode. You can see the Apple JPEG decode image all frame here. And so this JPEG image decode operation is taking about 32 milliseconds. And then the most interesting thing about this particular flame chart is that we have this additional integration that shows us slow and frozen frames directly on the flame chart. So if I hover over this UI frame, I see that there's a slow frame that lasts 75 milliseconds. And so of that 75 milliseconds, I know that this copy image block set with options function is taking 42 milliseconds of that. So we kind of know here that we're dropping a frame, and the cause of the dropped frame is this particular image decoding function. So in theory, like moving this off the main thread would result in you not dropping that frame, and that would improve your UI performance. So just to reiterate from where I started, a few different ways to take advantage of profiling data in Sentry. One is through the profiling landing page, which gives you a quick summary of the slowest functions in your app. The second one is being able to view the profiling data for a particular span in your transaction. Another example is for a missing instrumentation span, you're able to use profiling data to sort of fill in the gaps. And then finally, for a performance issue that we generate using profiling data, we can give you kind of like code level insight and links directly to the code where you need to start optimizing a performance problem. And so those are some ways to take advantage of profiling. And now I'll hand it back over to Linda.
I think Ash will actually take this slide.
Okay.
So yes, just to wrap up, in terms of our current support with regard to platforms for profiling, We have the most recent edition of PHP. So on the back end, we have pretty broad support, including Python, Node, and PHP. And then on the mobile side, we have both Android and iOS. We are currently working on both all Ruby.NET and JavaScript browser. Ruby is actually in a pretty solid beta state right now, and with both of the other two as kind of proof of concept. But these are all actively areas of work for us with the intention to deploy these as generally available products in the future. In addition, and this is something I didn't add on the list just because it's not something that we have really decided upon at this point, but we're evaluating the feasibility of React Native as another potential option for an additional platform, given just how much market share and how strong it is within the mobile space. So there are some specific technical issues that need to be addressed because that's a particularly hard one to tackle. But so we're doing some feasibility analysis right now, but we definitely have our eye on that and are looking to see how we can incorporate it into our product. And with that, I think we can go ahead and start Q&A.
Perfect. So we'll jump into the Q&A section now. We've gotten some great questions already in the chat, and we'll just work our way through them. And in the meantime, if you haven't gotten the chance to put in a question yet, feel free to use the Q&A function in Zoom and drop in your question, and we'll get to it as soon as possible. So the first question that we had during the stream that was asked was back when we were explaining a little bit about tracing versus profiling, but Ryan asks, are transactions equivalent to database transactions?
Indrajit, do you want to try to handle that?
Sure, yeah. So transactions are not equivalent to database transactions. So transactions are actually Sentry terminology for essentially it's just basically like a high-level operation with a start and end. So for backend services, a transaction is typically handling a request, right? So you might have a request to a particular endpoint, and whatever work you do to handle that request is wrapped up into this transaction. Transactions have spans as children, and spans can have other spans as children, which break down that kind of high-level thing into more sub-operations. So you might have a transaction for handling a request where that request handler calls out to a database or calls out to another service, and those will be represented as spans. And then for mobile, for example, a transaction could be like a screen load, right? So you press a button, it navigates to a new screen, and your transaction measures the from you kind of starting the load to when the content is fully rendered. That's a transaction. So it's kind of a flexible sort of container or a flexible sort of unit that represents some sort of operation. And spans are children of that transaction. So transactions are they can contain spans that point to database operations, but their transactions themselves are not equivalent to database transactions.
Well, thank you for clarifying, Indrajit. Our next question is from Anonymous, but they ask, does running the Sentry profiler affect the performance of our application?
Good question. So we do some performance kind of benchmarking to figure out the percentage overhead that running a profiler adds to the CPU time of your application. And so our target is always to make the overhead imperceptible to the end user. So a user using a product where profiling is enabled should not have visibly degraded performance because of profiling. So kind of in numeric terms, the number we target is roughly 5%. So we aim to not add more than 5% CPU time overhead while the profiler is running. Now that said, like the overhead depends on a lot of different factors, the hardware, the operating system, the specific platform you're running on, the configuration of your framework, for example. So that number is sort of like an average or like a typical case scenario. And a more precise figure is something you'd have to sort of benchmark yourself, but that's sort of in our internal benchmarks, that's kind of our target for how much overhead we want to add to avoid disrupting the user experience.
Perfect. And we've also dropped a resource if you want to read a little bit more about performance overhead. And the next question we have came from Richard, and he's asking if you guys can share some stories and results of how you've used profiling to improve your site performance.
I can probably answer this better with a link to some content that we've written, more so than a concise answer here. But basically, we've been using both our Python and Node.js profilers internally to fix performance issues within our own services. And so I can post some links to these resources here. So this is our blog post for Node.js. And then we have a similar blog post for Python, which covers some use cases. So for context, Python is kind of the primary development language used at Sentry for our backend services. And so both of these blog posts are kind of the results of us using our profiler internally to fix performance issues. And we're trying to write these kinds of posts for more languages, but these two are the ones that we have available right now, simply because Python and Node.js have the most kind of applications internally that we've tried this with.
Definitely feel free to check out those blog posts. They're pretty visual as well, so you'll be able to see the flow of what we did in Node and Python. And yeah, would love your feedback on if those are helpful too. Just for the next question, Ryan again. Thanks so much for the questions, Ryan. He's asking, does profiling work in the browser too? If checking a checkbox takes 2000 milliseconds for React to update, would I see that as well?
Yeah, so like Ash mentioned, we actually do have a profiling concept, proof of concept for the browser, and that proof of concept does capture React internals. So basically what you just outlined there, the 2000 milliseconds in a React render, that would show up in the profile. We're not quite ready to release it yet. There's some kind of, there are a few kind of technical roadblocks we're working around. The browser kind of like self-profiling specification is not finalized. And so we're kind of working with technology that's bleeding edge in flight. And so we have a working POC. We're trying to have it generally available within about the next quarter. But we can't kind of promise an exact timeline on that just because we're still doing some like technical feasibility analysis. But we do kind of have it working. So yes, if things work out, you will be able to debug slow React renders with the profiler.
Thank you. And the next question comes from the chat from Bogdan, and he asked, what is the difference between flamechart and flamegraph? And I know Ash had a short response in the chat earlier, but if you want to expand, would love to hear more.
Sure. So apologies if my response was a little bit cryptic or not quite detailed enough. But generally speaking, when we say flame chart, that is capturing a single event. So a single event that takes place, it will show exactly what the thread of execution is, where, for each basically 10 millisecond sample, what is the stack? What are all the functions that are being called at that moment? And you can look over time to see exactly what is happening within your code in terms of what functions are being invoked. Now, a flame graph is intended to be an aggregated measure, where if you take a bunch of instances of a particular code block or a particular span actually being executed, we want to essentially present an average or a consolidated view to the viewer, such that if in one instance, if there's a particular code path, like function A calls function B calls function C, and in one instance you spend 10 milliseconds, or you spend 500 milliseconds on that particular code path, and then in instance B, in that same code path, function A calls function B calls function C, you spend 400 milliseconds. You sum those two together, and for all of the events that are presented, basically you sum together how much time is spent on each particular code path, and then present that as an aggregated chart, where you can see on the average which code paths are occupying the most time for my code, by collecting all of the events that are running that same span. If that makes sense, I'm hoping that kind of clarifies like what the distinction is.
Cool, thank you for the explanation, Ash. We also have some docs written up about what's the difference between flame charts and flame graphs as well. So if you need some more time to digest as well, that would be a great resource. Cool. So the next question comes from David, and he's asking, hey peeps, thanks for this demo. Well, thank you for being here, David. He's asking, does Sentry have integration with incident response platforms like PagerDuty?
Great. So just to clarify, there is an integration for PagerDuty. I just linked to the document or the product page for it in the chat. If the question was sort of around general Sentry integration around PagerDuty as an alerting platform, then yes, the answer is we can support it for like issues and stuff like that. But if the question was around profiling data specifically and PagerDuty, so alerting in PagerDuty when, like, I don't know, some code runs slower or something, we don't support profiling in particular. But Sentry as a whole does have a PagerDuty integration for alerting.
Thank you for correcting me.
Well, thank you. I think we saw a comment come in quickly as well. It's asking if we can reshare the resources from the use cases. I believe when Indraji was mentioning the Python and Node internal use cases we had. So if you want to drop those in the chat, that would be super helpful. Oh, also Indraji, I think just a quick call out, but the chat function needs to be to everyone.
You saw that, yeah, thanks.
All good. Cool. And the next question that we had come in was from Rodrigo. And he is asking, he's saying that actually the majority of companies I've worked for do not properly set transactions/spans. He's saying or asking, would the profiling that Sentry has worked out of the box in that situation, or will we have to have clearly defined boundaries for transactions and spans to use the ID?
Yeah, I can take this one. So you don't necessarily need to create your own transactions because most platforms have performance auto instrumentation, which is basically just adding automatic transactions for specific platforms around common operations. So for example, if you were to use Sentry's Django integration, you would get automatic transactions around all of the requests that hit your service. So if you're using a platform that supports auto instrumentation, which is most of the platforms, then you wouldn't necessarily need to add your own transactions and spans. Those will be created for you automatically. If you have a kind of more of a custom use case where you wanted to add your own instrumentation around specific chunks of code, then yes, you would want to create your own spans, your own transactions. But in general, we kind of aim to provide a pretty good out-of-the-box experience for most common platforms. So I think the recommendation would be try the SDK for your particular platform and framework. And if the auto instrumentation works, then great. And then for the gaps where you don't see auto instrumentation, you would want to go and manually add transaction boundaries so you can take advantage of the profiling functionality. Perfect,
thank you. We have a lot of questions in the chat and probably around 10 more minutes to answer. I think we'll try to get to most of them, but our next question is, how do we manage what functions get profiling? Is there any concern with increasing execution times / page loads while sampling the call stack so often?
So you don't necessarily manage which functions get profiling individually. So profiling will capture all functions across all threads for the duration that the profiler is running. So the profiler runs during a transaction. So if you've started a transaction or an auto-instrumented transaction is running, the profiler will be running. And when that transaction ends, the profiler would stop. So for any functions that are executed during that time span, we will automatically collect that instrumentation data. And then the question about concern with increasing execution times and page load durations. So that's kind of the overhead question, right? So the 5% overhead is what we aim for as kind of like a rough measure. So in theory, yes, you would increase execution times or page loads by around 5%, which again depends on your specific use case. There's a lot of variables involved. So picking a single number for that is often not reliable, but the kind of summary of that is, yes, it will increase it a little bit because a profiler does have overhead, but we've specifically designed our profiler for production use cases. And so we aim to not sort of degrade the user experience of your application by significantly increasing the length of your page loads. So the user should never notice is kind of the summary.
Great, thank you. And we have a couple of questions all just regarding different supported SDKs and what we're planning to release. So I'll kind of bundle those together. We have Brad who's asking if we're planning on adding profiling to .NET MAUI once the .NET implementation is complete. We also have questions about if we're going to support for native C++ frames on mobile profiling, and if we plan to release for hybrid mobile apps. So just general, what's on the map for supported SDKs.
Yeah. So for hybrid mobile, I'll take that one first. React Native, definitely yes. So Ash mentioned we are currently in the middle of doing a feasibility analysis for React Native profiling. So we're actively working on that one right now. The next sort of major hybrid mobile platform that we'd like to tackle is Flutter. And then Ionic, we don't currently have any plans to do it, but it's definitely not off the table. There's no platform that's off the table. We're just kind of approaching them in order of priority based on the amount of like market share customers that are using that platform with Sentry. So for hybrid mobile, the order would be React Native, Flutter, and then everything else we would consider afterward. The C++ question. So for native platforms, so for C and C++, we don't currently support that generally. We do support it for iOS or Apple platforms in particular. So if you're running native code on Apple platforms, you can use our iOS profiler, or it also works on Mac OS, for example. So if you're running C or C++ code on those platforms, we can profile it, but generally we don't support it. We would like to support native profiling on C++ for sure. Linda, was there a third platform?
Yeah. Just to add on to C++, I think the user asked, what about OpenCV?
Yes, so OpenCV, yeah, again, it's a native library written in C and C++. And so when we add general support for profiling native code, OpenCV will be covered, but we don't support that currently.
Cool. What about Elixir?
Yeah, Elixir is another backend kind of framework. We would want to add support for it. We just don't have a time frame for it yet. So the next kind of immediate priorities for backend platforms are Ruby, which Ash mentioned we're working on already, .NET, Java, Go, and then everything else would sort of come after that. So yeah, definitely we'll consider it. But those are kind of the immediate platforms that we're thinking about for backend platform expansion.
Mm-hmm. Sounds great. We have a mobile specific question asking if mobile profiling includes support for frame times and vsync events to facilitate jank frame detections in ANRs.
Yeah, great question. So we currently don't draw the vsyncs. So that would be an augmentation we could add to the flame chart to kind of draw lines for the vsyncs. We don't really do that right now. We do, like I showed in my demo, identify slow and frozen frames along with the timestamps of those slow and frozen frames, but we don't currently render vsync stuff. Yes, in theory, that's definitely doable. We don't have support for it right now. It's currently not on a roadmap. Yeah, it would be like a good enhancement to sort of like the frame drop detection functionality.
Cool. Thanks for answering that. And we have a couple of questions regarding sampling. So for example, if we actually set the sample rate to something besides like 100%, will profiling still have some overhead? And also, someone also asked, is there a customizable like sampling rate like with performance monitoring?
So the first question was, is there overhead if you set a sampling rate, right? So,
yeah.
So the sampling rate that you set is essentially a client-side sampling rate. So that tells us for what percentage of transactions do you want the profiler to be enabled for. So let's say you set the profile sample rate to 0.5. That means that for 50% of transactions, you want to collect profiles. So for 50% of them, we will have the profiler running, and for the other 50%, we will not be running the profiler. So you will not pay the overhead for the 50% of profiles that you do not sample. And then, sorry, Linda, what was the second part of the question?
The next part of the question was just regarding, is it like automatically 100% sampling, or can we customize the sampling rate, like with performance?
Yes, the answer is yes. You can customize it. So in the documentation, you'll find the code examples for adding the profile sample rate parameter to your SDK configuration. We recommend 100% by default. So you'll get a profile for every transaction, but you can definitely lower that to a rate of your choosing.
Great. We have just a couple more questions and also just a couple minutes, but a specific question on if we can enable profiling for Django management commands. From what I saw up until now, the auto setup is only for URL endpoints.
Yeah, that makes sense. So the auto instrumentation is for kind of request handling. So you'll get automated transactions set up for any requests that your server handles, but for management actions, I don't believe there's like a default auto instrumentation integration. So what you'd have to do for those is you would have to kind of wrap your management commands in a manually created transaction. And then that would give you a transaction and also give you a profile if profiling is enabled. So basically for anything that the auto instrumentation doesn't handle, you would want to add custom transactions around that code.
Got it. And then we have a question about if the Sentry profiling functionality only works when an event is captured either by an unhandled exception or an explicit call to a Sentry's SDK method. They want to know kind of, is this not to be understood as an APM alternative?
Yeah, so the profiling works completely independent of kind of the error handling or error reporting functionality. You don't need to trigger an error basically for a profile to be collected. So profiles will be collected for any transaction, whether or not there's an error involved. And so as long as you are starting a transaction or the auto-instrumented transaction is being started, we will collect profiling data regardless of errors.
Cool. And I think we're going to have to cut off probably after this question. The other ones we can maybe quickly follow up in the chat, but when we were talking about sampling rate, I think Ryan asked if we set it our profiler to 50% and we capture an error, but that when the profiler isn't running, will the view profile button be missing on that particular issue?
That's correct. So you can have issues that don't have an associated profile. The solution to this is that in these cases, there's an all events tab for either a transaction or an issue where you can go to the all events tab and get similar examples of that event where there is a profile attached. So let's say you have a group of issues, right? And some of them have profiles and some of them don't. The one you're looking at might not have a profile, so you won't have the view profile button, but then you can go to the all events tab and then find an event that has a profile, go into that one, which will be the same kind of issue, and then you can view the profile for that.
Right. And can we see a list of built-in issues connecting to performance/profiling somewhere? That would be probably in the docs, right? Also, Andrew, you're on mute.
Oh, sorry. I'm just going to post a link in the chat to the documentation.
Perfect. Cool. And then, yeah, any sampling rate sweet spot recommendations for profiling is the last question.
100% would be the kind of default recommendation. The sweet spot would largely depend on the amount of kind of transaction volume generated from your application. So if you're a relatively low volume application, you're totally fine to send 100%. If you kind of want to reduce the amount of profiles you spend for like quota reasons, because you're paying for a certain number of transactions and you don't want to eat up the quota too fast, then you might want to decrease the sample rate. But we always recommend that people send 100% just because where possible, that does provide the best user experience. Like all of your transactions will have profiles. You kind of won't have sort of like these gaps where you have some transactions with profiles and some without. So kind of quota permitting, we would recommend 100%, but if you want to kind of reduce your usage, you always can.
Awesome. Well, I think that's a wrap for the questions. If you have any more remaining product questions, please do feel free to just reach out and email us. We're just an email away at profiling@sentry.io, and we're happy to respond to all of your questions there as well. And Thank you so much for joining us today. We really appreciate it. I'm going to quickly share my screen and share a couple of resources that you can also use to learn a little bit more about profiling. We do have a blog that we recently wrote up capturing some of our feature improvements for profiling that we announced at general availability just a week ago. And we also have an FAQ page that can answer perhaps some of the more commonly asked questions about profiling as well. So definitely feel free to check out those resources. And lastly, when we close up the Zoom, you'll see a survey pop up. We would definitely appreciate if you can take like 2 seconds to answer that survey because your feedback matters a lot to us. But that is it today for our Profiling Ask Me Anything live stream. Thank you so much to both Indraji and Ash, and also Dorothy, who is helping us run the event, for all of their time and energy. And of course, thank you all today for attending. We really appreciated and enjoyed interacting with you all and all of your questions, and hope you get to try out profiling, and excited to hear your feedback about the product. Bye all.